Hello guys, this is season 3 about ASPEN HYSYS software. And if you like my videos, please subscribe, write your comments about quality of teaching, like and press the bell icon so you can watch my next videos. Thank you. This season, I want to simulate three-phase separator and talk about it. Yes, this is three-phase separator. No, thermodynamic science and unit operation are important for simulation. All processes simulated by program can be analyzed. The correct analysis done by chemical engineers are done due to having sufficient knowledge in the field of calculation principles, how it works in thermodynamic science, and any ordinary person who has not studied chemical or polymer engineering cannot simulate by program. Now, I'm enthusiastic to talk about NRTL model. The NRTL property package is used for chemical systems and HF calculation with highly non-ideal chemicals. NRTL uses the following calculation methods for liquid: NRTL method for VLE, Cavet's method for enthalpy and entropy for vapor, ideal gas, RK, Virial, Payne-Robinson, and SRK methods for enthalpy and entropy, like the Wilson equation. The NRTL thermodynamically consistent and it can be applied to ternary and higher order systems using parameters regressed from binary equilibrium data. It has accuracy comparable to the Wilson equation for VLE systems. The NRTL equation in HYSYS contains 5 adjustable parameters: temperature dependent and independent, for fitting per binary pair. The NRTL combines the advantages of the Wilson and Van Laer intensive, and they can respect LLE quite well. Unlike the Van Laer equation, NRTL can be used for dilute system and hydrocarbon alcohol mixtures, although it may not be as good for alcohol hydrocarbon system as the Wilson equation. The 5 adjustable parameters for the NRTL equation in HYSYS are the AIJ, AJI, BIJ, and BJI, yes, terms. Due to the mathematical structure of the NRTL equation, it can produce Uranus multiple miscibility gaps. The NRTL equation in HYSYS has the following form. Yes, this is formula, and this is NRTL model, where yi activity coefficient of component I, xi mole fraction of component I, T temperature, N total number of components, AIG non-temperature dependent energy parameter between components, A and G calorie gram mole, BIJ temperature dependent energy parameter between components, I and J calorie gram mole Kelvin, AIJ NRTL non-randomness constant for binary interaction. Note that AIJ, AJI for all binaries. And The equation was parameter values stored in HYSYS or any user supplied value for further fitting the equation to a given set of data. And I want to talk about units. The energy related parameters in the NRTL model use units in agreement with the unit of gas. Yes, this is formula Kij Aij plus Bij T and the other, where the units are as follows. Kij, the energy unit same as R in calorie gram mole Kelvin. Aij, the energy unit same as R calorie gram mole. Bij, calorie gram mole, and Cij, calorie gram mole. Units of Bij, yes, are corrected with respect to temperature. And now I want to talk about general NRTL. This variation of the NRTL model allows to select the equation format for equation parameters T and X. Apply this model to system with a wide boiling point range between components where you require a simultaneous solution of VLE and LLE, and there exists a wide boiling point or a concentration range between components. Before today's simulation, I will talk to all of you about biodiesel fuels to prepare your mind. Biodiesel is a renewable and degradable fuel that is obtained from vegetable oil or animal fat. The fuel can be easily mixed with diesel and used in diesel cars. Another important point is the possibility for raising burnt vegetable oils to produce biodiesel. Burnt oils, which are used in large quantities in many places, including delights and thrown away at the end of day and the end of day can be used in biodiesel production. This is through phase separator, uh, temperature 140, pressure 14, mass flow 2,903, and we we choose or we select NRTL model for this simulation. Yes, and these are components and these are percentage components for this simulation. And now I'm going to open um, ASPEN HYSYS. Click on it. Yes, I choose new file, click on it. Yes, and now I'm going to add components. Click on it. At first, I search about M oleate. First component. Yes, I added. And what is M oleate? Or it's better to say, what is methyl oleate? Methyl oleate is a colorless or yellow liquid known by the chemical formula C19H36O2. This chemical compound is formed by condensation of the carboxyl group of oleic acid with methanol. Methyl oleate is also produced as a chemical for the production of detergents, surfactants, with which are used on esters such as sulfonated methyl esters, SME methyl ester, ethoxylate, MEE, and alkylamides, and the other. This chemical composition, this chemical composition has a boiling point between 200 to and 210 degrees Celsius. This chemical compound is mainly used as an alternative to methylbenzene, dimethylbenzene, and solvent oil in the manufacture of pesticide products. This compound is widely preferred in various industries due to its low toxicity and environment-friendly properties. Also, the demand for it in metalworking industries has increased as a lubricant and as a cleaner and degreaser. Yes, cleaner and degreaser. And mm, now I'm going to add the other component. Yes. What is the other component? Yes, methanol. Methanol. Yes, methanol. Methanol and the other component, glycerol. I apologize. Glycerol. Yes, exactly. I added the other component, water, and Yes. Trillion. What is trillion? Trillion is a triglyceride formed by esterification of the hydroxy groups of glycerol with oleic acid. Trillion is one of the two components of Lorenz's oil. It has a role as a plant metabolic and Cynorribes elegans metabolic. It is functionally related to an oleic acid or uh yes, all right. And now I'm going to add fluid package. It is really important. In the previous video I talked about it. Click on it, add, and I select NRTL model. Why I choose NRTL model? I choose NRTL model because the NRTL property package is used for chemical systems and HF alkylation with highly non-ideal chemicals. Yes, and now we are going to a simulation environment. Click on it. Yes, and now I choose material stream. Click on it, and yes, I write the name for this stream and add and enter temperature, pressure, and molar flow. Yes, and now I should I should enter percentage composition. Edit. Yes. I choose mass flow for this simulation. And now enter the numbers, enter the percentage composition. Look. Yes, click on it, and after that, yes, after that I choose three-phase separator. Click on it, and I'm going to change the name of separator, and for a stream I enter three-phase feed. Yes. All right. Okay, and now my three-phase separator is one. Yes. Finish, but I want to say something. Uh, Now I want to add show table. Right click, choose show table. Yes. We can see separator type, vessel temperature, vessel pressure, and the other. In the If you want to see a liquid mass flow or a liquid molar flow or the other, you can double click on show table and choose add variable and search this place. For example, mm, liquid molar flow. I want to see the number of liquid molar flow. Liquid, yes. Find it, click on it, done. Yes. And now we can see liquid molar flow on show table. I can do it again for us. Double click, add variable, and now I want to see the number of mass flow. Mass flow. Yes. For example, vapor mass flow. Yes. We can see vapor mass flow and show table. It's really easy peasy. And now I want to say something. If you're confused when you are working with HYSYS, you can get help from software. You can click on it. For example, you can click on it. Yes, this is help environment, and we can use it. For example, I wanna know about I wanna know about HYSYS simulation environment. Click on it and choose, for example, unit operation, unit overview. Yes. We can read it and learn many different things. For example, integrated steady state and dynamic simulation. HYSYS use an integrated steady state and dynamic modeling cap capability in which the same model can be evaluated from either perspective with full sharing of process info. In my point of view, this is really obvious. We can see useful, yes, we can see useful information about fluid packets. No, I apologize. We can see useful information about multi-flow sheet uh, architecture. For example, the multi-flow sheet architecture of HYSYS is vital to this overall modeling approach. Although HYSYS is designed to allow the use of multiple property package and the creation of per-built template, the greatest advantages of using multiple flowsheet is that they provide an extremely effective way to organize large processes. Yes, we can use help environment and yes. Okay, the time is over. The training ended today. If you have question, please write your comments or send message on Telegram or Instagram. Bye.